Hello students, today we are going to see numerical integration. Numerical integration. Okay. In this section we shall be concerned with the problems of numerical integration. That is, for a given set of values x0, y0, comma, order pair x1, y1, order pair x2, y2, and so on up to order pair xn, yn of x and y we shall derive formulae to compute numerical integration. Integration from x0 to xn y dx. Okay. We know that a set of tabular data points x0, y0 and so on up to xn, yn of the function y is equals to f of x on the interval x0, xn, where y is equals to f of x is not known explicitly. Okay. Now, integration of a set. In this section, we will discuss integration of a set of tabular data. The evaluation of integrals. A process known as quadrature or integration. The evaluation of integrals is known as integration. Okay. Now we will see some formulas for numerical integration. First formula is the general quadrature formula. The general quadrature formula, and that formula is I is equals to n into h integration from 0 to n y0 plus n by 2 into delta y0 plus n into 2n minus 3 upon 12 into delta square y0 plus n into n minus 2 square upon 24 delta cube y0 plus and so on up to n is equals to n is equals to 1 terms into du. This is the general quadrature formula for integration. Okay. Here your h is interval of difference and n runs from 1 to 3 and so on. Okay. Next is trapezoidal rule. Trapezoidal rule. That rule is integration from x0 to xn y dx is equals to h by 2 into y0 plus yn plus 2 into y1 plus y2 plus and so on plus yn minus 1. Okay, this is the trapezoidal rule. Let us write down one remark. The geometrical significance of the trapezoidal rule is the curve y is equals to f of x is replaced by n straight lines joining points order pair x0 y0 comma order pair x1 comma y1 and so on up to order pair xn comma yn. The area bounded by the curve y is equals to f of x. The coordinates x is equals to x0 and x is equals to xn and the x-axis is then approximately equivalent to the sum of the areas the n trapeziums. Okay. Next, see Simpson's 1/3 rule. This is trapezoidal rule. Simpson's 1/3 rule. Simpson's 1/3 rule, and that rule is integration from x0 to xn y dx is equals to h upon 3 into y0 plus yn plus 4 into y1 plus y3 plus y5 plus and so on plus yn minus 1 plus 2 into y2 plus y4 and so on up to yn minus 2. Okay, this is the Simpson's 1/3 rule. Here note that Simpson's one-third rule requires the division of whole range into an even number of sub-intervals of width h. Okay. Next, see Simpson 3/8 rule. Simpson 3/8 rule, and that rule is integration from x0 to xn y dx is equals to 3 into h upon 8 into in bracket y0 plus yn bracket complete plus 3 into y1 plus y2 plus y4 plus y5 and so on up to yn minus 1 plus 2 into y3 plus y6 plus y9 plus and so on up to yn minus 3. Okay, these are the formulas, you have to remember it. Okay, we will solve problems based on these formulas. First problem is evaluate integration from 0 to 5 dx upon 1 plus x using trapezoidal rule taking h is equals to 1. Okay, students, see here you have given f of x is equals to what? 1 upon 1 plus x. Okay, interval is 0 to 5. So here your a is 0 and b is 5. A means in formulas you have seen that integration from x0 to xn. So here your a is equals to x0 and b is equals to xn. Here a is equals to 0, b is equals to 5. Okay, and you have already given that h is equals to 1. Okay, see here 0 to integration from 0 to 5. So here your n is 1. N is 5. For n is equals to 5, we have the following step length. Step length means following step length and nodal points. Step length means interval of difference. Okay, if you have not given h, then you can use the formula b minus a upon n. See here b is 5 minus a is 0 and n is 5. So you will get h is equals to 1. Okay, then the values of y are given for the arguments which are obtained by dividing the interval 0 5 into 5 equal parts are given below. Okay, here interval is from 0 to 5. N is equals to 5, so we divide this interval into 5 equal parts. Here your argument lies in 0 to 5, means you have an interval from 0 to 5. We divide this interval into equal 5 parts, and you have, and here h is equals to 1. So 0 plus 1 is 1, means first argument is 0, second is 1, next is 1 plus 1 is 2, next is 3 plus 1 is 4, and 4 plus 1 is 5. So your arguments are 0, 1, 2, 3, 4, 5. Okay. What is your f of x? F of x means y is equals to f of x. So here y is 1 upon 1 plus x. Okay. So calculate. If you put x is equals to 0, then you will get 1 upon 1. So y0 is, this is the value of y0. If you put x is equals to 1, then you will get y is equals to 1 upon 1 plus 1, means 1 upon 2. This is 0.5. Next, put x is equals to 2. So you will get 1 upon 1 plus 2, means 1 upon 3. This is 0.333. This is y1, y2. Similarly, calculate y3. y3 is 0.250, y4 is 0.2, and y5 is 167. This is y3, this is y4, and this is value of y5. Okay. Now, in question you have asked that evaluate this integral by using trapezoidal rule. Okay. What? Using trapezoidal rule. What is that rule? Rule is integration from x0 to xn. Here xn is x5. Y dx is equals to h by 2 into y0 plus y5 plus 2 into y1 plus y2 plus y3 plus y4. Okay. Very simple. Put all the values of y0, y1, y2, y3, y4 and y5 in this formula and solve it. Okay. Here h is 1, so 1 by 2 into y0 is 1 plus y5 is 0.167 plus 2 into y1. y1 is 0.5 plus y2 is 0.33 plus y3 is 0.250 plus y4 is 0.2. Okay. Calculate this on calculator. You will get answer 1.866. Okay. This is 1.866 is the value of this integral. Okay. Let us take second example. Find the area bounded by the curve. Find the area bounded, find the area bounded by the curve, find the area bounded by the curve f of x and the x-axis from x is equals to 7.47 to x is equals to 7.52 from the following data. Okay, where x are 7.47, 7.48, 7.49, 7.50, 7.51, 7.50. Here y is equals to f of x. Values are 1.92, 1.95, 1.98, 2.01, 2.03, 2.06. Okay. Here you have to find the area bounded by the curve. Here we have to use trapezoidal rule. We use trapezoidal rule. And that rule is integration from x0 to x5 into y dx is equals to h by 2 into y0 plus y5. Here x5, so here is y5 plus 2 into y1 plus y2 plus and plus y3 plus y4. Why y4? Because here is 5, so here we take terms up to only n minus 1. Means here is y4. Okay. This is x0, x1, x2, x3, x4, x5. So its corresponding values are y0, y1, y2, y3, y4 and y5. So here y0 is equals to 1.92, y1 is equals to 1.95, y2 is equals to 1.98, y3 is equals to 2.01, y4 is equals to 2.03 and y5 is equals to 2.06. Okay. So area is nothing but your x0. You have to find area bounded by the curve, f of x and the x-axis from x is equals to 7.47. So your x0 is 7.47 and xn is 7.52. Okay. F of x dx, okay, which is equals to h upon 2. See here, difference of these two is 0.001, difference of these two is again 0.01. So your h is 0.01 into and here divided by 2. Now see, what is the value of y0? Y0 is 1.92 plus y5 is 2.06 plus 2 into, what is y1? Y1 is 1.95 plus y2 is 1.98 plus y3 is 2.01 plus y4 is 2.03. Okay. Now calculate this on calculator. You will get answer 0.0996. Okay. Okay, we will stop here. Thank you. In next video we will see some more examples on these formulas.